Hello. We're going to review some material that we covered in class on the virtual method. This is an example problem to support what we've been doing. I had to think a little bit and I came up with the idea of working on a zoo. Excuse me a second. So the concept is we're going to build a zoo. The zoo will consist of many animals. I'm only picking dogs and cats because I don't want to work really hard. And I don't want you to either. I want to focus on the main concepts. The idea is we're going to create a single variable that will hold different objects like dogs. It'll be able to hold cats and snakes, but not snakes on a plane. We'll skip that. All right, to do that, as we studied, we'll create a class. We'll create a class and we'll call the base class the foundation to handle or catch all the classes. We're going to call that an animal. In the animal class, well, we'll have a sound method. The problem is we're going to have different animals in there. Dogs, cats, chickens, ducks, lions. They make different sounds. So what I'm going to do is I'm going to say, I don't know what that sound will be, but whoever is an animal will have to define it for me. So that's why you see this weird syntax here. Virtual and the equal sign with a 0. It's weird. You just live with it. It's C++. What can anyone say? Then we can create all our individual classes. I say a snake is an animal and it has to create its own sound. The same with the cat. The cat must create a sound. The dog must create a sound. Now, what if the animal makes no sound or I don't want to do it? Sorry, you must create that method. Even if you blank out what's inside the method, it still must be created. All right, here's a zoom in on it so that you can see the syntax quite clearly in case your notes aren't that great. There's our method name, sound. Here's our animal dog. And the dog is an animal, and it makes the sound woof. Here we have our cat, and the cat is an animal, and it makes our sound meow. Here we have the snake is an animal, and the snake hisses. So I thought a little bit more. What can we do? Well, we could create an array to hold them all, and whatever number I put in there, the array would be fixed. That is fixed size. Well, we also have to then deal with keeping track of the index. So we need an indice variable that we are responsible to increment each time. So now, there we have it. Well, there we will have it. The animal vector. I don't have to keep track of the indices anymore. Why? Vector will do it for us. Notice it's still a pointer. That a zoo is going to be a vector of pointers, and they point to the different animals that we're going to have in our zoo. Of course, I have to write a class for each animal. Thus, there is no magic. So let's take a look at our main program. Here, we're going to have our vector, and it'll be a zoo, and zoo is where we're going to put all our animals, stuff them all in zoo. How do we stuff it in? Using pushback. There you see I have it highlighted, pushback. Now notice also I give people a choice. What do you want to put in our zoo? If you put in a number 1, we'll have a dog. Number 2 is a cat. 3 is a snake. And 0, I'm done filling up the zoo. Notice when you put in a 0, the break is executed and we will leave this loop. Easy enough. Well, another way to write that loop might be, well, actually not the loop, excuse me, going inside the loop, so let's go back. Inside the loop, I just want to look at this point right here. That's all I want to look at. And here it is. I still have the idea of I want to leave the forever loop, but now, instead of having a nested if-then, where I have to read so many if-elses, I just use case 1, case 2, case 3. And each one of them, I push back snake, cats, and dogs. Now another problem occurs. I have to remember all of these numbers. That 2 means cat, 1 means dog, and 3 means snake. What if I had 20 different animals to choose from? That's a lot of numbers to memorize just for a program. One of the ideas, remember, in coding is not just solving the algorithm, that is, having an algorithm or procedure or some methods to solve a problem. It's solving the problem in such a way as other people can modify it in the future. They can look at it, even you, years later, and say, I know what that program's doing. And also the other idea is, well, maintenance. Things change. Many times people call software a moving target. So we want to write our code in such a way as that we can add and take things away and we're in control of it. So one idea is, instead of using numbers, I could use words like cat, snake, and the word none. And how could I use it? Well, there are many different ways to do this. And I don't want to get too distracted here, but we could use a C language function called printf. Printf, you'll notice, takes a first parameter here, and you'll see these letter D's with a percent sign in front. That's an escape character. It means I want you to print out a number next. And if you look to the right, you'll see dog will line up with the first D, cat will line up with the next D for cat, and snake and none. You see they all line up, and this is what the output will be. Dog is 1, cat is 2, snake is 3. Now notice another beauty of this. Take a moment. I can change these numbers up at the top here. Oh, my mouse went crazy. I can change these numbers, and these numbers in the display automatically change. In fact, if I change those numbers, going back to the case statements, this works automatically if I do this. If I use those constants instead of numbers inside the switch statement for the cases. So I could make this 31, 42, 33. It doesn't matter what numbers I use. My program is a little more robust, a little easier to deal with, I hope. So now what happens? Well, we created a bunch of animals for a zoo, and we want to listen to them. So here I have a simple for loop that starts at index 0, goes all the way up to the last index. Notice I didn't have to keep count. The vector did it for me. And at each animal, that is, if you take a real close look here, here's the eye, this is an animal. It's going to be one of these creatures. It'll be a dog, a cat, a snake, and it'll call the correct sound. I don't have to keep track of it. The system will for me. When I'm done, we'd like to clean up our mess. So we use the operator delete, and delete will return each one of those objects, cats and dogs and snakes, back to the system's memory. I think it behooves you to sit down and dwell upon this and type it up manually and think about it. The next thing we're going to look at is the code. All right, basically you start off here, you have your IO stream, your vector, and I'm a little lazy, so I like using the namespace shortcut std. However, I've been reading more and more that it's a little too lazy and dangerous in the future, and should probably just spell it out, that is fully qualify, put std in front of everything that requires it. Well, here you go. Is the ordering of everything: the animal class, that is the pure virtual class, followed by the declarations for concrete classes such as dog, cat, and snake. Of course, what I did here is I couldn't resist changing the code one more time after speaking about it. Anyway, I made the constants global so I could use them throughout the program from this point down. So I did some changes. I couldn't resist. Taking a look at this code, it's really nice. It's kind of compact, but cramming that in the main program, because the main program's real idea is to ask you, what type of animal would you like to make? And let's hear them at the end and then clean up. Not all the gory details of creating a new dog, a new cat, and how to do it. that shouldn't be so, shouldn't be sitting there on top. So what I did was I took it, and if you look carefully, I took that piece of code, cut it out. I take the choices and put it in a function, take the choices input, and based on that choice, I create a creature. And it's a pointer to an animal, and I simply return that pointer. Return it where? Well, I'm going to return it into that loop where it was before. I'll say zoo.pushback that makeAnimal. And notice the main program is, I think, a lot cleaner to look at. It gets the point across. If you look at it really carefully up there, it says zoo pushback makeAnimal based on your choice. Oh, that's pretty clear. And here it is again. Don't know why it's going that way. Ah, the keys are backwards. Here's a sample run. Fill zoo with, you know, cats, dogs, snakes. 1, 2, 3. So that's dog, cat, snake, cats, snake, cat, dog. Done. And you see the output is correct. And that's some program to think about. You don't have to worry about cats, snakes, and dogs so much, but it could be people, it could be aircraft types coming into an airport. The zoo could be any container type thing in the real world. It's kind of up to your imagination, sort of like in the Matrix.